IT project management. In this module, we will study what it takes to analyze a risk from a qualitative and a quantitative standpoint. Here is what you will learn in this module. You will apply several qualitative and quantitative analysis techniques that can be used to prioritize and analyze various project risks. But before that, you will learn how to use established taxonomies for risk likelihood and consequence. This will take us through qualitative risk management. Then we will start to measure risk probability and impact and develop our own taxonomies. This will lead us into risk factorization and expected monetary value to evaluate a risk quantitatively. In the end, you will be able to not just plot a risk on a risk matrix, but explain a risk's financial impact on the project outcome. So, let's jump right in. Qualitative risk management, and quantitative as well, is based on the equation in the yellow box here. Risk is the result of a combination between a probability, or likelihood, and the consequence, or impact. In fact, to get the value of a risk, we multiply probability and impact. But we need numbers for multiplication. So here's how we get those. Remember the risk identification taxonomy, which was a list of categories that showed us aspects of our project about which we could ask questions to help us identify, that is, make known, the risks on our project? Now we use another taxonomy, but this time it helps us determine the probability of a risk. It ranges from remote on the left side to near certain on the right side. Pause this video for a moment to take a good look at these 5 categories, then come back. As you can see, each category describes in as much detail as possible the probability level that we can assign here. You may now be tempted to say, but what if I think the probability of my risk is 10%? That's not the point here, though. In fact, many organizations ignore any percentages at this point, but they do this. They just number the categories from 1 for the lowest likelihood, to 2 for unlikely, to 3 for even chance or 50-50, to 4 for highly likely, and to 5 for the highest likelihood. Remember this risk? Let's say that it is September now. This means that March is still 6 months away. Will there be a funding crisis in March? Perhaps. That depends on the company. How likely is it that the risk will come true? We assume that funding should have arrived by then because the organization is currently recovering from financial problems. We review the categories on a probability taxonomy. So, given the current trend in the organization, we decide that it will be unlikely that the organization will run out of money and assign a value of unlikely or 2 to this risk. We just said that each risk is the result of probability multiplied by impact or consequence. And we have defined the categories for probability. So our next step is to define the categories for impact and consequence. I keep saying impact or consequence because both words are used in organizations and they both tend to describe pretty much the same thing. In most organizations, you will find the same number of categories for impact that you have for probability. Since we had 5 categories for probability before, we will have 5 categories for impact as well. If we had 4 categories for probability, we would have probably 4 categories for impact and so on. All right, let's take a look at our first category, minimal. That is the smallest impact with the fewest adverse consequences. Then we have minor, then major, which is starting to make us want to do something about the risk. then serious, and finally catastrophic. Do you notice how each of the categories is broken down into 3 bullet points? The first one, technical, is clearly about scope and quality. The second and the third ones are schedule and budget. In other words, this taxonomy for impact helps you consider the impact of the risk on the triple constraints of your project. And we know that the fun stops when schedule, budget, or scope and quality are in jeopardy, right? Where in an organization do you find these taxonomies for probability and impact so that all you have to do is look up the numbers for each risk? Usually, you should get these definitions from your friendly PMO, the Project Management Office. If there is no PMO in your organization, your finance department definitely will have and use these taxonomies. Let's go back to our example risk. Let's do the same thing as we did before and use the taxonomy to help us figure out what the impact value should be. If payroll cannot be funded and staff is cut, well, fewer people means that our work will slow down significantly. And if the most important technical people are being cut from the project, we may not be able to complete the project at all, so it may fail, or the quality of the work may degrade because we may need to find people internally who can finish the work. Oof, that's pretty serious, wouldn't you say? Let's take a look at the impact taxonomy and see where we end up with this. We're seeing that we should have probably done some schedule forecasting, as you have learned in earlier modules of this course. So in the technical and schedule categories, the risk probably falls somewhere between major and significant. But since there is a chance that the project may fail entirely, that pushes it towards serious. So we decide to assign a severity of serious or 4. Sometimes, though, it can become the project manager's job to define the taxonomies herself. Now, return to the risk register from the previous exercise. Look at each of the risks that you have written down, and then decide how you would want to describe the categories in a taxonomy for likelihood or probability at the top of the slide, and for impact or consequence at the bottom of the slide. Pause the video and write those definitions down. Use your own taxonomies that you have just developed to determine the probability or likelihood scores and the impact scores for your 2 risks. The goal of evaluating risks qualitatively is to plot them on a risk matrix like the one you see here. We typically find impact or consequence on the horizontal x-axis and likelihood or probability on the vertical y-axis. Here we see 3 risks already plotted. Risk A with a probability of likely and an impact of minor. Risk B with a probability of near certainty and catastrophic, and risk C with a probability of near certainty and an impact of major. Now let's plot our previous risk. We said that the likelihood was low, but that the impact was serious. This means that if low is 2 and serious is 4, our risk value is an 8. We can now plot our project funding risk, let's call it P, on this matrix. Why do we do this? Because these matrices are a great way to visualize where a risk falls on the spectrum from green, which usually means watch, to red, which means address right away. Many organizations decide the cutoffs between green, yellow, and red based on their risk tolerance, meaning how much risk they're comfortable with. So the color of the fields can differ slightly between organizations. Why do we want to visualize our risks? Well, think about it this way. When you initially planned your project, whether waterfall or agile, did you plan that things could go wrong? Probably not. So your budget is not designed to pay to address any risk, correct? And now in come all of these risks that require money to address them. Lots of money. So you have money available to pay for people, schedule, wait times, that kind of thing, but that money is limited. This is why normally project managers get to include between 5 and 10% contingency, that is, extra budget on top of the calculated project budget to address some risks, but not all of them. You have to pick and choose which risks to address first, second, third, and so forth. A risk matrix like the one that we just saw can help you rank your risks and determine which ones to address and which ones to just watch to see if they'll go away on their own or if they will get worse. Many companies stop at qualitative risk assessment. They don't proceed to the next process, quantitative risk assessment, but we will. So instead of just plotting a risk on a risk matrix and determining visually how and when to address a risk, we now want to do the money math. We want to figure out how much it will cost to address each individual risk. Perhaps that will change our risk ranking. There are a number of different ways to quantify risks. Some of these should look familiar to you. You came across the first two, for example, in our module on project selection in an enterprise. Why? Because a project is always a risk for the organization. So we can use this kind of math to quantify the organization's risk of actually undertaking a project with you as the project manager as well. Any kind of quantitative risk analysis is a cost-benefit analysis. The easiest calculation is to determine what an impact will cost when we allow the risk to come true. Then we will want to determine what the cost would be to do something about the risk. We call that the response cost. But as we already know, our available project money to react to risks is limited. So if it costs more to let the risk happen with all of its impact than to do something about it, we respond to the risk and do something. If it costs more to do something about that risk rather than just letting it happen and absorbing the impact, we decide to let the risk happen. That's a very basic calculation. What if a risk is only moderately likely to happen, let's say at 50%, for example? Then we would multiply the straight impact cost by 50%. What if there's a probability of only 70% that your risk response will work? Then we multiply the response cost by 70%. Then we compare the numbers and apply again the rule of thumb in the green box. Here's our example again. Remember our qualitative calculations from before. Now we calculate impact. We said before that without people, our project may fail. If our entire project has a budget of, for example, $50,000 and that project fails, the organization will be out either just the actual cost at the point in time at which the project fails, or even the entire project funding. We say that is $50,000. However, if we instead start training more people on the inside and revise the project schedule, notify all stakeholders, rebuild our network diagram and all that, we may be out only $20,000. We may be able to save the project. At that point, it looks like we will want to do something about this risk because needing an extra $20,000 sounds better than losing $50,000, right? But what does this look like when we take into account that the likelihood for this risk is only low, which according to our earlier taxonomy means 15%. If we factor the impact cost, that is, we multiply our $50,000 by 15%, we get a factored impact cost of $7,500. If we factor our response cost and take into account that the response will be 100% effective and cost us $20,000, things look different, don't they? At this point, it seems better to wait and see if the risk happens. Another way to quantify risk is our second option, expected monetary value or EMV. For this calculation, you need to estimate the cost for all probable outcomes and the probabilities for these outcomes. Look at the chart on the right. The risk here is the combination of cause and consequence, but the cause of a subcontractor going belly up here has 3 possible consequences: a late system delivery, overtime, or contract changes. The probabilities are 60%, 30%, and 10%. Note that all probabilities always amount to 100%. So the expected monetary value for consequence 1 is 60% times $500,000, which is $300K or $300,000. The EMV for the second consequence is 30% times $2 million, which makes it $600K. And the third consequence is 10% times $1 million, which makes it $100,000. If we sum the values of all consequences, we get the total expected monetary value of this risk. Now note, this result of $1 million is the EMV for the straight risk, with all its consequences and the probability of having to spend a certain amount of money on them if they occur. If the risk itself is going to happen at only 70%, then we might want to multiply the EMV by 70% as well, and factorize it that way. If all the alternatives are very close in value, we might apply the PERT technique you have learned for estimating, which is optimistic plus pessimistic plus poor times most likely, then everything divided by 6 to find the best financial middle ground. The opportunities here to refine your estimates of how much a risk is going to cost are endless. Most organizations require factorization as shown here, though. Back to our example again. Remember our qualitative calculations from before? While we can keep the low for 15% to categorize the overall risk, we need to estimate the probability of occurrence for each of the potential consequences in the EMV tree. Here's the EMV tree. And here are our 2 consequences. We assume that it's 70% likely that the project will be canceled, so we assign a 70% probability to the first of the 2 consequences, which will cost us $50,000 or the actual cost at termination of the project. This means there is a 30% probability that we get to do something about, we say mitigate, the risk for the $20,000 we had calculated earlier. We do our math here, and we see that the value of this risk with both alternative solutions is $38,000. Now we can take those likelihood percent, which was 15, and multiply the $38,000 by the 15%, and out comes $5,700. We can now set those $5,700 aside in our contingency budget to possibly pay for this risk. But we need to continue to monitor its likelihood and redo this calculation as the likelihood and the consequences change. Now go back to the laptop example again. Think about how much it will cost to replace the laptop, to get your backpack from the other room, to buy an umbrella, or maybe to email your friend to bring her cell phone over so you can call and ask for an extension, or to share her data plan so you can back your file up into the cloud. Then pause this video and build your own expected monetary value, that is EMV tree, to determine the value of this risk, similar to the one you see here. How many consequences can you think of for just one of the risks from your previous list? Remember that all percentages must add up to 100%. Here is what you have learned in this module. You have applied several qualitative and quantitative analysis techniques that can be used to prioritize and analyze various project risks. You have used established taxonomies for risk likelihood and consequence to perform qualitative risk management. Then you have measured risk probability and impact and developed your own taxonomies. You have evaluated a risk quantitatively with risk factorization and expected monetary value analysis so that you were able to not just plot a risk on a risk matrix, but explain a risk's financial impact on the project outcome. Here are the words that you have learned in this module. Please ensure that you can define and explain each one of them. Thank you for watching. I look forward to seeing you in a future video.